This is lesson 3.2. Students are working on the warm-up right now. 1, 2, and 3. And then number 4, where there's lots of possible answers for A through F. And good review over some vocab. Maybe about 1 more minute to try those. And we'll go over the right answers. Again, you might want highlighters today or different colored pens when we're going through the notes. Okay. Name a plane parallel to plane QRZ. So you're talking about the right edge of this rectangular prism. All right, folks. What plane would be parallel to this one? Who's got it for me? Alejandro?
SPX.
SPX would work. Obviously, I have 4 letters here, so any combination of those 3. He said SPX. I said PSW. However, you want to do a combination of the 3 points on that plane. Make sure you have plane written in front of it. Good. Parallel planes. Name 3 segments parallel to RS. Line segment RS. All right. Who can give me one of them? Alex? WZ. Those are both on like the front plane. Remember, parallel lines have to be on the same plane. That one? Matthew? XY. Good. And that's because we have that plane. I'd like cut this in half. Remember that diagonal plane? We could draw a plane through those 2 line segments. Okay, and the last one you should have had PQ with that top plane. Oopsie. Whoops. Okay. It's okay. Skew to PX, this line. All right, so remember, skew means they cannot be on the same plane. So I kind of showed you that strategy last time, just like eliminate all the line segments that are on the same plane as this one, which would be the back face and the left face here. All right, so it only says you have to name 1, but some options here. We could have line segment WZ would be skew, ZY, SR or RS, and RQ. Why could I not say RZ as it's skew? Matthew, I feel like this one's your specialty.
It's parallel.
Right. They are technically parallel because I could draw a plane that's parallel. Or I'm sorry, I could draw a plane through those 2 lines and that would make them parallel, right? Okay, good. Any of those would have been correct for number 3. Okay, now number 4. Lots of different options here because I have a couple ways I could look at this. I could say, hey, line S and line T are my 2 lines and line M is my transversal. Or I could say L and M are my 2 lines and S is my transversal, okay? So I'll kind of just go through and just list some possible. Obviously, there's like infinitely many ways you could like list these answers. So corresponding angles. I started with using L and M as my 2 lines and S as my transversal. So let's just review over corresponding angles. You zone in on the intersection angles with the transversal, and it's any angle that's in the same location. So I said 1 and 13 because they are both in that like upper left-hand corner. So any like intersection point when they're in the same location. Okay. Alternate interior angles. I still used L and M for this example, but this time I said, what about having T as my transversal? Alternate interior. Well, first of all, in order to be interior, you have to be inside the two lines. Alternate means opposite sides of the transversal. So I said angle 6 and angle 10. Again, one or more possibilities. Looking at the same setup, we could say 9 and 7. Alternate means other side of the transversal. So alternate exterior, let's just stick with this example for a second. Now I'm looking at these four angles, 5, 8, 12, and 11. One's on the outside. Alternate still means opposite sides of the transversal. So angle 8 and angle 12 would work for alternate exterior angles. Okay, so kind of hard to check your own, but just make sure that yours make sense with what I'm like saying as we're going over this vocab again. Consecutive interior. This time I switched it up. I said, okay, let's look at T and S, and maybe this time M is my transversal. Interior angles would be 15, 14, 9, and 12 inside the two lines. Anyone remember what consecutive means? Same side of the transversal. Yep. So I could say 12 and 14, 9 and 15. I said angle 12. My red pen is not doing so hot. And angle 14. All right, those are all our new vocab words from last lesson. Now, vertical angles and linear pair, that's a review. Oh, cool. Vertical angles would be any two that are like across from each other at the intersection point. Okay. I said 10 and 12. Linear pair are any two angles that form a line. 11 and 12 form a line. 5 and 6 form a line. 13 and 15, 1 and 2. Lots of options here. I said 5 and 6. Linear pair, two angles. All these you should have two angles. Okay, that's a refresher over 3-1. Now 3-2, the angle relationships is not new vocab word for us. We're still going to talk about alternate interior, corresponding, but now we're going to talk about the relationships with the measures of these angles if the two lines are parallel. Okay, so I'm going to say that like 15 times today. This only holds true if the two lines are parallel. So right here in my notes, I wrote, only works if the two lines are parallel. Okay, and I'm going to highlight this in each of these hypotheses. You'll see if two parallel lines, so again, I wrote right here, this only works if the two lines are parallel. The following 6 things we're going to talk about. No, 5. 4 theorems, 1 postulate. These only work if the two lines are parallel. Okay. First postulate. Remember, postulate is just something we accept as true, even though there's no like way of proving it. If two parallel lines, and remember how we mark something's parallel is by these like arrows. If the two lines are parallel and they're cut by a transversal, there's no line here, I'm just going to highlight in blue, then each pair of corresponding angles are congruent. Okay? So here, if you want to use your highlighter, you can, or you could do this too, like this angle is going to be congruent to this angle. Okay, so corresponding angle, remember that means like same location. So that's why I highlighted 1 and 3. Those are both in the upper left-hand corner. Those are going to be congruent. Can somebody give me another pair of corresponding angles in this picture? 1, 2, and 4. Those are going to be congruent. We'll talk about why in a second. Two and 4. 5 and 7. Excellent, I made those red. 5 and 7 are corresponding angles. They're both in the bottom right. And 6 and 8. So they're all going to be congruent. Okay, here's why. However you want to mark it. You can use like the congruency marks, or you can use highlighter. Well, first of all, just like look at the angles for a second. If we were to take like a protractor and measure angle 1 and measure angle 3, don't they look like they form the same angle? They're obviously both obtuse, right? And if these two lines are going the same direction and they never intersect, obviously whatever angle the transversal makes with this one is going to make the same angle with this one because those are the same line. Okay? And obviously that's true for any of these angles that's formed by the transversal. Okay? Corresponding angles are congruent. We use this little postulate a lot. Oh, the corresponding angles, they're congruent if the two lines are parallel. If and only if the two lines are parallel. Okay. Now I have a few theorems. Alternate interior angle theorem states if, again, the two lines are parallel and they're cut by a transversal, right there, those arrows indicating to me that they are parallel. Each pair of alternate interior angles are also congruent. Okay, so I only labeled the interior angles for you. Remember, interior means inside the two lines. Alternate interior means opposite side of the transversal. So in this example, 1 and 3 are alternate interior angles. They are congruent. They have the same measure. And so do 2 and 4. So angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. Okay, here's why, folks. And you don't have to prove this to me. You just have to know this. Okay, but here's like just a little mini, not a 2-column proof or anything serious. Just a little explanation as to why this holds true. Angle 1 is going to have the same measure as whatever this angle is. Let's say this one's 6. You don't have to write this down. But these are not the same measure because they're corresponding. Right? Now these two angles are what? Vertical, which means they are the same or congruent. Transitive property. If this one's congruent to this one, and this one's congruent to this one, then these two would also have to be congruent, right? Alternate interior angles. Alternate interior angles. Okay, and then that'll work for the pink ones as well. With me? All right. Here's the relationship between consecutive interior angles. If the two lines are parallel, and they're cut by a transversal, parallel, and these arrows, cut by a transversal, this one right here, consecutive interior, which means inside, that's why I only labeled those 4, inside on the same side of the transversal are supplementary, meaning they add to 180. So 1 and 2 are consecutive on the same side of transversal interior. 4 and 3, consecutive interior. Or sometimes you'll see this as same side interior or same side exterior. And this always would hold true that these will add to 180 because they're supplementary. Angle 1 and angle 2 are supplementary. We know what that means. That means their angle measures add to 180. Okay. Let me quick explain why this works. Okay, I don't have to write this down. We know corresponding angles are congruent. So let's say this is angle 6 again. Angle 1 and angle 6 are going to be congruent. What's the relationship between 2 and 6? Supplementary. They're a linear pair. They're supplementary. So this angle plus this angle adds to 180. And this angle is the same as this angle. Then these are also going to add to 180. Okay? Let's say this angle is 100 degrees. This one's also 100 degrees. What would this one be? 80. Supplementary. So these, 100 plus 80, also supplementary. Okay? And that works, folks, for same side interior and same side exterior. Alternate exterior angles. We're almost done. We got 2 more. Then we'll do some examples. Alternate exterior, if the 2 lines are again parallel, cut by a transversal. Alternate exterior angles are also congruent. Okay, so this time I labeled the exterior angles for you. Alternate meaning opposite sides of the transversal, like 5 and 7, or like 6 and 8. Those angles are congruent. So if they're exterior angles laying outside the 2 lines and on opposite sides of the transversal, they're congruent. If you don't have highlighters, you can just do like these markings. Congruent, 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 congruent. Okay, really quick, here's why. Angle 5, we know it's congruent to this angle. I'm going to call it 2. Corresponding. 2 and 7 are congruent. Why? Vertical. So if this one's congruent to this one, this one's congruent to this one, transitive property, those would also be congruent. All right. Last theorem. This one kind of feels like a common sense theorem. If my transversal, again, this works if these 2 lines are parallel, A and B are parallel. So let's write that down. If line A is parallel to line B, that's from these markings. All right. If the transversal is perpendicular to one of the lines, I'm calling my transversal line T. So if we know this, if we know the 2 lines are parallel and the transversal is perpendicular to one of the lines, it's going to be perpendicular to the other line as well. Then line B is also perpendicular to line T. Okay, that's basically our new stuff for today. Now we're just going to do some example problems. I do have a little like coloring activity we're going to do really quick. We're just going to kind of shade in some examples of each. If you don't have different colors, you know, you could do like polka dots for one, stars for another, stripes, whatever you want to do. I'm just going to quickly and just give you one example of each. But I kind of like this like little cheat sheet of what's equal to each other and what adds up to 180, what's supplementary. Okay, I'm just going to do this pretty quickly. So, corresponding angles I'm going to do in red, or if you have different color pens. An example of corresponding angles would be this angle right here and this angle right here. Okay, hopefully we know that from doing our homework from yesterday. What's new for today? Woo. Okay, it's not going to let me color anymore. Knowing that those are congruent. Those are equal. Okay. What else is new from today is that we know alternate exterior angles are congruent. So I have lots of exterior angles here. My example of alternate ones could be this one that lies on the right-hand side of the transversal. And this one, let's see, let me color, yay. That lies on the left-hand side of the transversal. Those would be alternate exterior angles. They would also be congruent. Their angle measures are congruent. This we already know. We already know vertical angles are congruent. Okay, an example of vertical angles would be this one. This is kind of a fun little coloring game. And this one. Obviously, why didn't she do these two? Could have done that one. side interior, that's also consecutive interior. I'm going to do these ones in green. These add up to 180, or these are supplementary. So same side, I'm going to go to the right-hand side of my transversal. Interior would be this one and this one. Alternate interior, I only have one pair of angles left, and these ones do lie on opposite sides of the transversal. So we could label, color those. Alternate interior are congruent. Last one. Sorry if I'm going fast. This is basically just exactly what we just talked about. Same side exterior. Same side exterior, such as these two. Those would also add up to 180. Okay. I'll let you kind of fill that in. But I kind of like this as just like a little cheat sheet. Just keep in mind, these are only one example of each. There's different ways. I can take that off a little bit. I want to make note this only works if these two lines are parallel. This relationship. All right. Let's see how many of the example problems we can get through together. We can definitely get through this one. All right, here we go. Example problem. In the figure, the measure of angle 11 is 51 degrees. Let's go ahead and write that in. Find the measure of each angle. Tell which postulative theorems you used. Now they're showing us right here that these two lines are parallel from this marking. So that's great. They want us to find the measure of angle 15. What's the relationship between angle 11 and angle 15? You can shout out.
Corresponding.
They're corresponding, right? They're both in the upper right-hand corner. Corresponding angles are congruent. So this one's also 51 degrees. You can just say by corresponding. All you need to know is the measure of one of these, and we could find the measure of all of them. Okay, so we know that this one and this one are congruent, 51 degrees. Find the measure of angle 16. Now, you could be looking at angle 15. You're like, oh, they're vertical angles, right? But let's try and connect it back with what was given to us. What's the relationship between 16 and 11? First of all, they're both exterior. Matthew, what's their relationship? Alternate exterior. So pretend for a second we didn't know this one. Just pretend. Based on what I was given, I see 11 and 16 are alternate exterior. Alternate exterior angles are congruent. So this one's also going to be 51 degrees by alternate exterior. And you can shorthand that if you want. All right, it doesn't ask me to do this, but could we figure out what angle 10 is? What is it? Anybody do that quick math? Jessa? 129, because these are a linear pair. These are supplementary. Now, there's lots of ways you could complete this puzzle. This one's also 129 because these are vertical angles, or these are also supplementary, right? 13 and 14, alternate interior angles are congruent. This one's also going to be 129, which makes sense because these are supplementary. These are vertical. Okay, so lots of different ways you could go through and complete any angle that they ask you to find. Next example here. The following diagram represents the floor tiles in Michelle's house. If the measure of angle 2 is 125 degrees, so this one right here, find the measure of angle 3. All right, so what's their relationship here? They're on opposite sides. This is the transversal for these two because that's the one they share. I think I heard it. What did we say? Alternate, opposite sides of transversal. Interior, yep. Alternate interior angles are congruent. annoys me so much. Not you guys, the smart board. Okay, it's still not lined up very well, but 5, alternate, and 2. Hold on, don't flip over yet. There we go. Okay. What if I asked for the measure of angle 1? Based on what's given to me, what's the relationship between these? Between 1 and 2. Don't overthink it. You could say they're a linear pair or they're supplementary. All right, so that one would be 55 degrees. So you could say 5 supplementary. Okay, so now that we know this one is 55, 4, a couple ways you could figure out 4. It's supplementary at 3. We could say it's alternate exterior with angle 1, so it's going to be congruent to angle 1. 5, alternate exterior to angle 1. Okay, now that wasn't given to us. So you're like, why couldn't I use angle 3 and say that they're supplementary? You could. There's, like I said, there's more than one way to find these. Okay, let's do at least number 1 here, finding x with algebra. And maybe we'll save this one as a warm-up. The last one here. Use the figure below to find the indicated variable. Explain your reasoning. Okay, we've got lots of parallel lines here. M's parallel to N. P's parallel to Q. They said the measure of angle 5 is 2 times x minus 10. Measure of angle 7 is x plus 15. All right, looking at these two angles, I see the transversal is M. So these are corresponding angles, meaning what about their measures? Congruent, the same. So 2x minus 10 is the same as x plus 15. Explaining your reasoning by corresponding. All right, solve this quick. X is 25. We could plug that in there, and you get both of them to be 40 degrees. Okay? Last one. Let's try to squeeze it in. Measure of angle 6 is 4 times y minus 25. 8 is 4y. All right. Their transversal is this one. So they're both exterior. Are they alternate or same side? Same side. So when they're same side, and usually we call them consecutive interior, but for exterior, we usually say same side. That doesn't mean they're congruent. That means they're supplementary. That means that these add to 180. If they were alternate, they would be congruent. But if they're the same side, they add up to 180. All right, I'm going to go ahead and solve this quick. You get y to be 35. by plugging these back in. If you plug it in for angle 8, you get, what is that, 140. If you plug it back in here, you get 40. Oh, I forgot this marker thing. You get 40. And our 140 and 40, are those supplementary? Yes, those add to 180. All right, let's pass on the first sheet quick.
High school football players are reminded that you'll have equipment turned in tomorrow, Tuesday, after school at 3:30 down at the weight room. Please make sure you have all practice gear washed and everything ready to turn in tomorrow. We'll follow up that equipment turn in with the meeting. Thank you. Everyone have a good evening.
All right, just a reminder, guys, the homework that's due for tomorrow is the grade 1 book. This one will be due Wednesday.
Teacher notes already down there?
Needs it.
What? You need it for your next test?